Trigonometric ratios of complementary angles. So what you can do here is we have a triangle with this particular angle being theta. This is 90. So with angle sum property, this will be 90 minus theta. So my request is now pause the video and try to find out all this trigonometric ratios. Right, there are 6 over here and 6 over here. So write them down. A by h, b by h, h by a, so on and so forth. So write the trigonometric ratios. Right. So now we'll begin with sine theta. Sine is opposite. So with respect to theta, that will be my opposite and this will be my adjacent. So opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Tan theta is opposite by adjacent. Cosec theta is inverse of sine. So I'll just copy all of this. Right. On the same line, try out writing sine of 90 minus theta, cos of 90 minus theta, so on and so forth. So basically we are over here. So we are looking at this to be our opposite and that to be our adjacent, right? So sine is opposite by hypotenuse, cos is adjacent by hypotenuse, and sec is, okay, not sec, tan. Tan is opposite by adjacent. While cosec is, we're looking at cosec is h by b, h by a. We're just copying this by inverting that, that's all. A by b. So the next step is match the following. An element from a ratio from here, match it over here. So example, sine theta, which is a by h, is equal to cos of 90 minus theta, which is also a by h. Okay. So cos theta is equal to sine 90 minus theta. Can you see that? B by h and b by h, same ratios. So this will be equal to what? Yes, cot of 90 minus theta. This is equal to, correct, sec 90 minus theta. And this is equal to sec theta is cosec 90 minus theta. And 6 cot theta is, yes, tan 90 minus theta. Right? We have matched it. So exactly what is happening over here? See, it's just a matter of perspective. If I stand from here, my opposite is A and my adjacent is B. If I stand at the other end, my opposite is B and the adjacent is A. Is it not? So as per all of these definitions, things are changing here and there and you end up with such ratios. So you basically end up with sine theta being equal to cos of 90 minus theta. So exactly what it means, I'll show you with an example. Sine 30 is cos of 90 minus 30, which is cos of 60. So all of this is equal to half, right? Tan 60 is tan of 90 minus 60, which is equal to tan of 30, which is equal to root of 3. Sorry, 1 by root 3. My bad. This is cot of 90 minus 30. Cot of 90 minus 30, which is cos 30. Cot 30, which is root 3. Cosec 45 degree is sec of 90 minus 45, which is sec 45, and which is root of 2. Okay. So basically, it's just a small observation that if you stand over here, the ratios will be same as some ratio when we stand over here. Okay. So if you stand at point A, some of the ratios will be equal to, not some of the ratios, all of the ratios will be equal to some other ratio if you stand over point B. That's all. That fact we are stating in a very different way, and that is your topic, trigonometric ratios of complementary angles. So what is complementary? Complementary angles are angles which add up to 90 degree. So theta plus 90 minus theta will give you 90 degree, is it not? So this two will add up to 90. So they are complementary angles. Okay. So basically we can end up writing sine theta is equal to cos of 90 minus theta. Similarly, cos theta is sine of 90 minus theta. Then next pair is tan theta is cot of 90 minus theta, while cot of theta is tan of 90 minus theta. Okay, so I mean, it's just a matter of understanding how we got it, and it's not that difficult. So based on this, we have numericals. They're also quite simple. So next is sec theta is cosec 90 minus theta, while cosec theta is sec of 90 minus theta. Okay, so this is something which we need to memorize, and this kind of makes sense, is it not? We have three sides, and depending on where you stand from, the opposite and adjacent side will change, and so our definition will change. I mean, definition will not change, but the values will change. Sin theta will have a different value. Sin 90 minus theta will have a different value. So when we mix and match, we get to observe that, okay, sin theta is equal to cos of 90 minus theta. And this can also be seen in your trigonometric ratios of specific angles also. So let me take some random value so that we are satisfied with what we just learned. Secant 20 degree should be equal to cosecant, as per this definition, 90 minus 20 degree. So cosec 70 degree. So secant 20 is what? 1.064. 1.064. So let's see if it's approximately or exactly same. I mean, it's too long. We can't sit and memorize that. That will not make sense. So this is your cosec. We can see it's the same thing. 1.064. So yes, this holds good. All these facts, all this observation holds good. So you can pause and make a list of this. We'll be using this and solving quite a few numericals.